Thanks to all of you for staying with us here. We have one more presentation before we'll head off to lunch. And I was hearing about this backstage, and I'm excited to see this one. We're going to be talking about taking NaaS to the next level with network APIs and AIOps from Shawn Hakl, who is Vice President of 5G Strategy at Microsoft Azure. Shawn?
Is that the clicker? All right. Cool. So I'd like to start off by thanking Nan for the much coveted just before lunch on the last day spot. I appreciate you guys' sense of humor at showing up. So I'm going to go into something that I think is a little bit more out there, right? I was involved with MEF before I went to Microsoft. I stayed involved with MEF for some important reasons. I actually think for the health of the telecom industry, we need to keep finding new sources of revenue and new approaches to driving value and services. And that ultimately, as we talk about network as a service, it's super cool to talk about SD-WAN and next-gen firewalls and all the cool stuff we're doing with SASE. That's a precursor. But where you really think about ultimately where this could go, you're trying to drive to network as a platform, right? If you want to create value in a differentiated network, it's got to be consumable, not just by the applications, by the developer community, as a way to create and build new services on top of that. And that's that's why I feel the work at MEF is super important, is because MEF takes a lot of the friction out of the process for making that happen between carriers. It gives a platform to scale, and it gives an API-based approach to managing the life cycle of these services, for which all the cool stuff I want to show you today can't exist without. And so I want to walk through a little bit today of sort of our vision of where network as a service could go. And essentially, part of my job is the joy of going around and talking to the CTOs and CEOs of operators and enterprises around the globe to talk about sort of what network, differentiated network can do for them. And what I would posit is when you think of network as a service, ultimately that's what they're after. They're after that next generation AI-driven experience that simplifies stuff that they can build the next generation's apps on. They can build experiences that are simpler, more secure, and more resilient. For us, this, the way we look at this is it starts, obviously, we feel that a common carrier-grade hybrid cloud platform is important, the ability to distribute functionality where you need it and when you need it. Then obviously building that next generation, and I think this is sold to this audience already, that the next generation of software-based services, having the infrastructure as software and controllable and exposed is an important next element to that. And then really what that's guiding you to is an AI-powered operations model where you can build new services that are more differentiated and more specific to specific industries without driving up a massive level of complexity that becomes unmanageable and unwieldable, whether or not you're a managed service provider or an operator. And then finally, what essentially that lets you do is expose that next generation of modern connected applications. So we hear a lot about Industry 4.0 and the value of those communications. A lot of you are looking to take the sale of traditional IT-based services into the OT space, and that involves another set of complexity and challenges, whether or not that's for IoT or next generation industrial networks. But a lot of that is centered around kind of this network as a service model. And so this is, I wanted to share a little bit sort of the two baselines of making that happen. Again, I think, you don't need a sales pitch on cloud, so I'm going to skip the bottom layer. The next layer up, I think many of you are providers of software-based services, so I do want to talk about a little bit about what it looks like to do more of that API exposure, as well as what that next generation of AI-powered operations looks like. And this is an effort that we're doing. So right today, the MEF has a lot of the lifecycle management services, and that's missing from some of the other industry results or industry efforts that are out there. And I've been working closely with Pascal and other members of the MEF committee to join up the efforts that MEF is doing around lifecycle orchestration, lifecycle automation, along with trying to get basic network telemetry and services exposed on a common basis across the industry to the developer community. So I think that's one piece of the conversation that's been missing here, is you're out talking to the enterprises, we're off talking with the operators, but the last step of the table is to bring that developer community to the table so they can build that next generation of applications that use the features that can be deployed by a differentiated network experience. And so essentially what we're suggesting is that you're going to have a distributed fabric of compute and network that allows you to deploy capabilities where you need it, when you need it, and then managed carefully with a fully exposed API basis so that developers can tie into that, use the power of the network, build their services assuming certain functionality is available, telemetry capabilities out of the network that don't exist otherwise. And once you've got this exposure out there, that's the basis for really driving forward with the network as a platform, which I think is ultimately the real vision of network as a service. And again, what becomes abstracted from that is, listen, it can be 5G, it can be, because everybody's hyped on that right now. It can be large-scale broadband deployments, awesome, because they're everywhere, and ultimately bringing a satellite into the equation as well, so you've got sort of ubiquitous coverage for these scenarios, but abstracting all of that away from the different developers that are out there and operating that. So essentially what we're doing right now within the MEF is trying to join up the lifecycle automation functions, the inter-carrier business operations that allow us to build and deploy these services with sort of a partnership with the Kamara Alliance, which is sponsored by the GSMA, which is all about figuring out how to expose the raw network telemetry up and out of the network. We'll expose that also as well. We're reaching out to the TM Forum, who have a similar effort to gather that all together. So you've kind of got the wireline perspective, the wireless perspective, and ultimately the MEF LSO as being a unifying function across that to make sure that we can talk independently between carriers. So again, there's been more discussion on this. I just wanted to get people bedded in with why there's so much outreach to these other standards organizations and really ultimately how it comes together to create value for the operators and the community in terms of exposing and creating a network as a platform vision. And again, obviously from an Azure perspective, what we essentially would like to do is take and bring the power of our developer community to the operators and the ecosystem that supports the operators. Building a developer ecosystem is expensive. Compiling that is challenging. Once you've got that, the more functions and the more capabilities we can bring to the table, the better off it is for us helping accelerate development within the ecosystem. Now, we have something called Azure Programmable Connectivity, which is essentially how we'll bring all this stuff together. That's not a competition to the MEF. It actually builds on top of it. In other words, we have to provide an interface to our developer community. We get it to scale when there's a common response underneath that. We actually need functions like Kamara, like MEF, that drive that commonality across the industry and drive that scale. And then it makes it possible for us to take it to our developer community and really bring them in. And so as network operators look to differentiate their experience and make more of their capabilities in their network available, we want to be able to expose that together, and that's what we're driving towards. So that's one thing as we look at sort of network as a service. The other half of this discussion, beyond being able to have kind of those exposed, is what are you going to be able to give to the developer community? Where are you going to be able, what are you going to be able to differentiate? And that's again where we're working with a number of operators across the board, as well as our software ecosystem, to actually build those use cases where a differentiated network experience matters. So I often get asked, okay, that's great that you can do all this network as a platform. How do you monetize it? Well, the mechanics of monetizing it, awesome. We've got MEF to help us make sure that we can deliver that common experience across operators. And then we have the capability, once we get all of that in place and we make that commerce smooth and easy, we're able to build on top of that, whether or not it's delivering the next generation of better communications across different operations, reaching into the next generation of connected scenarios. And again, I would argue that some of these are more wireless in nature, but honestly, I think at some point it's going to become irrelevant about which was the underlying network, and you're just going to use what the capabilities that are available, and we'd like to help accelerate that because I think it helps the industry overall grow. And so, as I said, I just want to give you some examples, I won't drain the slide for you, of where we're seeing the opportunity that's created by exposing the network as a platform. The other place is in AI operations. So everybody's talking about Gen AI and AIOps. We made a little purchase, you may have heard of it, that changed a few things. I wanted to give you a view of how we're anticipating the use of generative AI technology in the network management space. And if you think about it, this is optimized. Our view of AI is it essentially becomes a co-pilot, a set of functions or features that helps a human operator make better decisions. And network is ripe for this, because if you think about it with, how many of you have been in a NOC or a SOC where everybody's looking at 12 monitors from different systems and different vendors up there? You've got manuals open on the table, or people are searching in the internet quickly to understand where the challenge is. you've got the challenge of correlating a lot of disparate data in and then bouncing it off of a bunch of specialized knowledge. This is where generative AI can play a role and help out with that. And that's where we really see that next generation, again, network as a service combined with AIOps to really propel the delivery of network-based services. And again, the underlying standardization, the underlying orchestration, the stuff that MEF is doing in this space is important, because without those building blocks, this stuff is cool, but it's not implementable because it becomes too complex of an integration challenge on top of the disparate systems. So really where we're at today, and many of you may have seen this with the GitHub Copilot, which is essentially where we use the GitHub assets combined with large language models to generate code. In this case, I'm showing you an example of where someone just types in, hey, I want to see the reason for disconnects based on CDR data over a fixed time code. Now, and then they pop into the generate, and actually what comes back is the query language that the operator can use. So instead of going to an IT staff, instead of going to a specialist or the vendor to get it done, your ops person can type what they want in plain English, take it, generate it, and boom, done. So think of that, the speed of which you can get new data and sort of the empowerment you're giving to your frontline operations staff in terms of executing stuff. This is another one for anybody who's run a managed service business. They'll appreciate you can run this in reverse. As you know, in many cases in a managed service business, you're actually looking at stuff that was done beforehand that is almost incomprehensible to figure out, and you're trying to decode what the person before you did. So run that in reverse, where, oops, if we can go forward to the next one, where we actually ask the language to explain code that exists today and have it come out in sort of standard language models. So this is in cases where we've taken a complex query on TCP performance. This actually probably is a wireline example, and it explains essentially what that queue is doing. Again, think about the acceleration of support in your managed services staff or in your NOC services staff for figuring out what's going on. So not just helping you with new stuff going forward, but the legacy. So that gives you kind of an idea when we talk about these models and how they can apply what's state of the art today, right? So this is all today available functionality. Where we ultimately want to go is we want to take and cross-correlate that. We want to be able to take input from multiple systems, apply, so essentially bring in the data across multiple solutions, apply that across different technologies and the underlying support information that's available, whether it's the vendor's website or it's an operations manual or it's or previous trouble logs, et cetera, and apply the incoming data to the event and help the operator make better decisions faster. So I'm going to play this now. I'm going to actually ask Austin to pause it as we go through each step. But essentially what you're going to see here is how an AI-based copilot, and this is future truth, this is not current truth, this is where we're going. If we can pause there, Austin, would be great. Essentially what we've got is the AIOps copilot has detected an anomaly condition in the network. So essentially it's bringing data in from the different network elements that are out there. In this case, it's a session management function in a wireless network. I apologize, I didn't have a enterprise SD-WAN example available. But essentially what it's saying is, hey, here's the situation of what's happening, so flagging the anomaly in the network. Hasn't hit thresholds yet, but flagging something's happening. But more importantly, it's going out to all the data sources that are out there and actually telling the operator what could be going on. And if you want more information, it gives you the ability to dive in and link further and do the exploration on your own. So essentially, a much more junior staff has the ability to diagnose much more complicated faults with full of information available and all the expertise that's in the model that may have come from your more experienced operators. Austin, if we can hit play, that would be great. So basically, in this case, the operator is asking in natural language, hey, can you look at what's going on and tell me what to do? If you can pause there again, Austin, would be great. Again, it gives you a natural language readout of what's going on in the tool. So this is all tooling that exists today. This builds on top of existing capabilities. However, it's just assembling it and portraying it to the operator in a much more consumable form. And ultimately, again, you can see beyond sort of the large language intersect models and the query tools put together with things like I just showed you on the GitOps pilot model, we can actually tell the operator what kind of command language to execute to resolve the problem. And so as a result, again, It gives them a code suggestion. You always want the operator looking at the code because it may, it may require tweaking. It does require human intervention. It just gives you essentially best practices and a tap on the shoulder that says here how it could go. And again, you always have the option to dig in to understand the reasoning that underpins the model in case you see something that you're not sure you agree with. Or you can click in and do more editing as a human being along with that. Whoops, I have to go. Anyways. I'm going to, just in the interest of time, skip the rest of the demo, but in fact, what the rest of the demo will show is the ability for you not only to execute that code, to track the results, the engine can give them further recommendations on what to do to prevent it in the future, as well as, more importantly, the last step is customer communication. You can get a full transcript of all the stuff that's going on, and then that transcript can be turned into a consumable summary. And if you think about that, that as a managed service provider, as a carrier, the things you want to be able to ship to your customer very quickly is, hey, there was an error, we had a problem, this is how we fixed it, and this is how we're going to change it going forward. Rather than having somebody spend an hour typing that all out, the system generates it for you based on what you've done prior to that. You review it, you send it out. So as a result, you can see how much more efficient, more effective. So essentially, from an operations perspective, you can incorporate more technology from more suppliers. You can get better results. Essentially, you have a constant expertise available on tap to support your operators, and you're making the best use you possibly can over disparate information sources to get the most accurate, rapid response. And then finally, you can use basic tooling to help you generate customer-friendly responses quickly. So I just wanted to give you a feel for, as people are building out network as a service solutions, that's awesome. They are the building blocks to be able to power an AIOps future. And I think that's where people, in my experience, get super, super excited. So I just wanted to give you a feel for a little bit about where I see network as a service going. And again, if come back, why does this matter? Well, it's awesome that MEF is putting together a comprehensive NaaS vision because it gives purchasers certainty on what they're getting and why they're getting it. Orchestration and automation underpins this. As you can tell, in order to get all of that integration working together smoothly, you have to be able to give quality inputs and code-based solutions to the engine to process it. I particularly appreciate the willingness of MEF to partner across other industry efforts. Lots of people are trying to solve piece parts of the solution. All of them are important building blocks to make this happen. And then again, another big thing is, from a hyperscaler perspective, is always the ability to scale. The more that we can standardize this across operators, the more that we can make these capabilities available generally, the more interest in the developer community you get, which means the more applications will be using these functions, which means the network will matter more and that quality of differentiated network experience will matter, which I think is ultimately super important to the industry as a whole. So again, I appreciate your sense of humor at staying with me just before lunch. I'm right at time, so I'm going to stop there, but happy to take questions at lunch if that works for you. Thank you very much.